Hi guys, welcome back to another example of an hint integration question. So in this example, I'm going to use the problem table algorithm method to solve this problem. As you can see in this problem, we have 6 streams, which is divided into 5 hot streams and 1 cold stream. So now we need to extract the informations from the streams. And the first step is we need to calculate the adjusted temperature based on a delta T minimum. So for this example, I've chosen delta T equals to 10 degrees Celsius. So next, let's look at the steam population table. So on the first column, we have the temperature interval arranged from the most hottest to the most coldest. And the next column, which is also known as the steam population column, where the streams are drawn based on each temperature intervals for the hot and cold streams. These streams are the hot streams, and this one stream is the cold stream. And moving on to the next column is the delta T, which is the temperature difference between each interval. And the next column, which is the summation of cold heat capacity subtracted by the summation of hot heat capacity. And the next and the last column is the delta H interval. Is basically taking the delta T interval multiplied by the summation of heat capacities for that temperature interval. We will obtain the answer for the delta H interval. And these steps are repeated throughout the rest of the temperature intervals. Next, we will take the temperature interval and corresponding delta of enthalpy of each temperature interval to form a heat cascade. So the purpose of this heat cascade table is basically used to identify the pinch point as well as to construct the grand composite curve, and also to identify the hot and cold utilities. So for example, let's look at how to construct this heat cascade table. So for this temperature interval from 665 degrees Celsius up to 495 degrees Celsius, and the corresponding enthalpy is 3060. So 0 will be subtracted with 3060 to obtain negative 3060. This is the accumulated enthalpy for this temperature interval. And this accumulated enthalpy will be later subtracted with 240 for the next temperature interval to obtain negative 3300. And this goes on until you obtain the most negative value for the heat cascade. And this most negative value of the heat cascade will be later shifted to the next heat cascade to identify the pinch point. From this heat cascade, you could also identify the hot and cold utilities. The hot utilities, which is 3620, and the cold utilities, which is 160. And also you could identify the pinch point temperature, which is at enthalpy, which is at 0, which is corresponding to 375 degrees Celsius. Another main reason why we shifted from this cascade to this cascade is because we need to create a positive enthalpy.
So as you can see, there's 6 available streams. There's 5 hot stream and also 1 cold stream. So there's the supply temperature, target temperature, the heat value, and also the CP, where we can calculate from the delta T and also the H. So we'll start with the hot composite curve. So we will start constructing the curve with the x-axis is the H and the y-axis as the temperature. So there's 5 hot streams, as you can remember just now. There's 5 hot streams, and this 1, 2, 3, and 4 and 5. There's 5 hot streams. So after we plot the five curves 5 straight lines. You can see that there's delta t interval, as you can see from the lines. So after that, we can combine all the 5 hot composite curves lines into one hot composite curves. So in order to combine the curves, we have to first identify the temperature intervals, which is the first one, which is started from the bottom, which is the 320 and to 360. So from this interval, we can see that there's 1 and then there's two lines that is intersecting. So we will be combining both of them together into one. So to calculate that, first of all, we need to calculate the delta t, which is 320 to 360. So the delta t is basically 40, and also here also same 40. So we'll be multiplying the CP value, which is 40 times 6, which we will get around 120. And here we'll get 40 times 12, we'll get around 480. So add up 480 and also 120, we'll get around 720. That's where we get the first temperature interval. So from 320 to 360, we'll get 720. That's where we get the first composite curve. So after we complete the first curve, we'll move on to the next temperature interval, which is the 360 until 380. So basically there's 4 lines intersecting the temperature intervals. So we can calculate, okay, the delta T is 20. 20 times 6 will be 120. Sorry, 120. And the next one will be the same as well, because the CP is 6, so it's 120. And this value is 20 times 20 will be 400. And this one is around 20 times with 12, we'll get around 240. So after we add on everything, 120 plus 120 plus with 400 and also 240, we'll get 880, plus with the previous one, which is 720, which we will get around 1006. So we completed the second delta T interval, so in between 360 to 380. So we'll continue moving on to the next, which I will not repeat again. So good luck on that. So now we'll move on to the cold composite curve. As I mentioned just now, there's only one cold streams. That's why we can just draw one straight line there. Just one straight lines, and we'll get the cold composite curve and the hot composite curve. So we combine two together to form the composite curves, and this is where we get the composite curves. Alright.
So now we'll be explaining about how to draw a grand composite curve. So this is an example of a grand composite curve. A grand composite curve is actually drawn by using the data from the heat cascade. So now let's have a look on the heat cascade that we have done just now. So this is the heat cascade that we have done just now. We've used the data from this column, which is the temperature interval, and this column from here to here to draw the grand composite curve. This column is actually the temperature intervals after being adjusted with delta T minimum, and this column is the cumulative enthalpy. So we'll use these columns to construct the grand composite curve. The temperature intervals will be our y-axis in the grand composite curve, while the cumulative enthalpies will be our x-axis in the grand composite curve. So let's get back to our grand composite curve. Actually, we start drawing grand composite curve from the bottom to the top. So this will be our first point. And this first point is actually extracted from heat cascade, which is 295 and 160. 295 will be our y-axis, y coordinate in the grand composite curve, while 160 will be the x coordinate in the grand composite curve. And this 160 is actually the co-utilities for the pinch analysis that we have done just now by using delta T mean equal to 10. And this 3620 will be our hot utilities. So we'll start drawing 295 match to 160, 215 match to 520. This will be the first point, and this will be the second point, and subsequently the whole diagram will be plotted. And from here to here, this little gap here will be our co-utilities, while the gap here from here to here will be our hot utilities for delta T minimum equal to 10. And note that, please take note that in our drawing, the y-axis doesn't really refer to a fixed scale, which means that from 295 it jumps to 315, and from 315 it jumps to 355, which means that we do not have a fixed scale to draw the y-axis. While this is actually acceptable in drawing the grand composite curve. So the purpose of having this grand composite curve is used to later on to decide which kind of utilities is suitable to compensate the needed utilities for our pinch analysis design. And we also found out that from after carrying out pinch analysis at different delta T minimum, we found out that delta T minimum equal to 10 is actually the best. Why? Because from here we can see that it has the least heating and cooling utilities. And we also observe that when we increase the delta T mean from 10 to 40, the pinch point rises from, the pinch point decreases from 375 degrees to 360 degrees. So after carrying out pinch analysis at different delta T minimum, we suggest that delta T minimum equal to 10 degrees will be the best delta T minimum because it gives the least heating and cooling utilities compared to other delta T minimum. I think this is the end of our presentation. Thanks for watching.